A recurring decimal is a decimal number that only consists of digits repeating after a fixed interval after the decimal. There are different ways of showing a recurring decimal, like a line or a dot above the number. The third example here, the dots are above the 5 and the 3, which indicates that they are repeated indefinitely. In our first example, we're going to put 0.4, repeating 4, in fraction form. Start off by assigning the value to f. You can use any variable letter like x or y or anything. Then multiply your whole f equation by 10. And now subtract your 10f and f equations from each other. The reason we subtract them is because 4.444 repeating subtracted by 0.444 repeating is 4. So the decimal values cancel each other out, and it leaves you with an integer. That is the most important thing to know when converting to a fraction. The decimals has to be the same. 10f minus 1f is 9f, and 4.444 repeating minus 0.444 repeating is 4, as shown previously. Then divide both sides by 9 to get f on its own, and now you have your answer, 4 divided by 9. If you are allowed to have your calculator, type 4 over 9 in to double check if you have the right fraction. Also, always check if the fraction is in its simplest form. Example number 2. Write 0.18 repeating 18 into fraction form. Same as the previous example, assign the value to f, then multiply your equation by 10. If you look closely, you can't do this example just like the previous one, because when you subtract the values of 10f and 1f, the decimals does not cancel out. Thus, it is not an integer. An integer being this fancy capital letter Z. Go back to your equations and multiply by 10 again. Now you can see that the 100f and 1f has the same decimals, which means that when they are subtracted, the answer will be an integer, which is the name of the game. Subtract your 1f equation from the 100f equation, then you are left with 99f equal to 18. It is 18 because the decimals cancels out as shown. Divide both sides by 99 to get the f on its own, and then you have your answer. 18 divided by 99 can be simplified to 2 over 11. The last example is the most difficult, but with some critical thinking you can get it right. Write 0.234 repeating 34 into fraction form. Always start off by assigning the recurring decimal to your variable. And now you want to get two equations where they have the same decimals. Multiply your f equation by 10. Decimals are not the same. Multiply 10f equation by 10 again to get 100f, and see, the decimals are still not the same. Don't be worried, just carry on. Multiply the 100f equation by 10 again, and now you can see that the 1000f equation has the same decimals as the 10f equation, which means that when their values are subtracted, you will be left with an integer because the decimals cancels out. Subtract the 1000f by the 10f equation, and then you are left with 990f equals to 232. Divide both sides by 990, and then you finally have your answer. Simplify the 232 over 990, simplify to 116 over 495. Thank you for watching, and I hope you understand recurring decimals a bit better now. Good luck on your math journey.